Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Hello, everybody, and welcome to the latest episode of Lunch with Tech Leaders. My name is Adam Oberhausen. I'm the Director of Cloud Architecture with Right Brain Networks. Had some logistical challenges today with Tom and Joe, so they're not going to be here, but it's just me and some guests. And today we're going to be talking about Kubernetes. What is Kubernetes? How did Kubernetes come to be? What are the key features and benefits of Kubernetes? What are the different components that make up a Kubernetes cluster? We're going to touch on the learning curve for Kubernetes and how to get started, and then we'll round the conversation up with talking about some best practices. So we got a lot to cover today, so grab your lunch and buckle up. Allow me to introduce our subject matter experts today. With us today, we've got Brendan Theed.
Theedy, yeah.
Sorry.
That's all right.
As I was saying it, I realized I don't know how to pronounce your last name. Welcome, Brendan. Thanks for joining the show. Feel free to introduce yourself and tell us a little bit about yourself.
Yeah, so I'm Brendan, and I've been kind of in the, if you want to call it the DevOps space, for going on, I don't know, about 10 years now, to various capacities. And then specifically around Kubernetes, I really went deep in that about 5 years ago, where I was working as a platform engineer, so kind of building abstractions on top of Kubernetes and managing installation of it. So yeah, I've had a lot of experience with using it. Definitely have used it wrong, have used it to make things better, worse, indifferent. So yeah, excited to talk about it.
Awesome. And we've also got with us today Matt McLean. Say hi, Matt, and tell us a little bit about yourself.
Hey everybody, my name's Matt McLean. I work for Doc Network, where they call me the DevOps Engineer Supreme, and that really means there's only just one DevOps engineer at the company. So there you go. And one of the first things we did was we migrated from ECS to EKS. So implemented Kubernetes at Doc Network, and have been really going in that route for a year. Now that wasn't my first time getting into Kubernetes. Of course, I started there in LlamaSoft, where I was spinning up Kubernetes clusters with Terraform and all of that, so we could run load testing clusters and such. So I've been playing around with Kubernetes for several years, but at Doc Network, we've been running all of our infrastructure on K8s for a little over a year now.
Awesome.
Yep.
Well, thanks guys for joining us. I usually like to start the show with a little bit of history on the topic. So if you guys have can fill in the gaps on anything I'm about to say, or correct me if I'm wrong anywhere. But from what I researched for this show is in the early 2000s, Google developed an internal container management system, which they called Borg. And they were, at the time, Google was struggling to manage their rapidly growing infrastructure. Right, early 2000s, Google's blowing up. So they developed what they called Borg to provide a more efficient, scalable way to manage containerized workloads. It used a distributed architecture with centralized control plane and a fleet of node workers, and it allowed them to manage containerized workloads at scale. And then in 2014, Google developed what is now known as Kubernetes as an open source project. What I'm not clear on is if Kubernetes is, from what I saw, is like Kubernetes is heavily influenced by Borg, but there's a lot of differences there. It's not like they just took Borg and made it open source. It's like a whole new thing. And then pretty much like Borg, Kubernetes was designed to provide a platform for managing containerized workloads. And then in 2015, Google donated the Kubernetes project to the Cloud Native Computing Foundation. And I mean, ever since then, it just seems like it's blown up. Like it seems like it's the most popular container orchestration tool out there. You can't stop hearing about it. It's been in the market for 8 years now, and it just seems like the popularity is growing and growing. What I did find interesting was that Google uses both Kubernetes and Borg internally, so they didn't retool everything to use Kubernetes. So the two systems have some strengths and weaknesses. I don't know a lot of the details there, but it sounds like Borg is still used extensively at Google for managing many of its internal services. And it's a very mature system, battle tested, all those things. And then, but Kubernetes has also become an important part of Google's internal infrastructure with like newer projects and anything that they're doing in the cloud, deployed to the clouds. Kubernetes is seen as more flexible and modular than Borg. So I don't know if you guys have looked into
Yeah.
it, but does that kind of add up? Anything to add or any
Yeah.
holes there I missed?
Well, and actually, I believe that Google has actually moved on from Borg to Omega is like the newer thing that they have. But when they created Kubernetes, which is exactly what you were saying at the end there, they wanted to have something that was more adaptable to common use cases, not Google specific. Like they didn't want you to have to assume that you had exactly their infrastructure. So there are a lot of decisions they made around Kubernetes to make it more generally applicable. So that would be kind of the key thing is, Kubernetes was meant to solve more problems than just those specific to Google. And so and from what I understand, it was just, complete rewrite. It wasn't like, forking the repo and tweaking it. It was just, no, we're going to take these conceptual themes and just write something from scratch.
Yeah, it's really fascinating to me. Like I'd wonder, like the strategy behind it is fascinating to me. I'd really like to know like why they did it. It seems like it's super popular platform right now. One of the questions I have for you guys is what were people doing before Kubernetes? Like what were they? I haven't worked much with containers, full disclosure. I kind of went from doing things on EC2, and then we kind of jumped straight into serverless. So I kind of I haven't done much with containers. I've worked with Docker, yada yada yada, but just like what were people doing before Kubernetes was around?
I mean, I know what I was doing. It was, using eventually infrastructure as code, I should say. Before that, it was, a lot of click ops, where you give a Word doc to an operations person to have them install some sort of a web server. Back in the day for me, it was a lot of web logic. So you have the web server, and that's kind of your abstraction layer. And so you have to build everything within the confines of what that web server exposes. So if you want to use its built-in queues and caching and the way that it's going to handle resource connections and stuff like that. So it's going to be very specific to what vendors you tied into and stuff like that. And so then when we went to containers eventually, it was around trying to avoid having to create dependencies or install dependencies on a specific virtual machine, putting things onto hardware and instead having that ship as part of the artifact, which isn't quite into the orchestration level of things yet, but I'll let Matt chime in.
Yeah, to be honest, I wasn't using containers before Kubernetes. We were using instances and virtual machines and running virtual machines in a cluster. People were just starting to use Heroku and services like that to run a container, but that Kubernetes came out right at the right time as people started to really look at containers. And I believe that it was the CNCF and Kubernetes and all of the tools around it that really enabled the containerization and the microservice movement to really happen in a solid way. And I mean, there's so much that's come out of the CNCF that today is just, bread and butter tools for DevOps type workloads and environments, right? And Kubernetes wouldn't be what it is without those components, right? Like etcd and core DNS. Those are fundamental into how Kubernetes runs, and that's all came out of the CNCF. You're right. This is all past Google. I mean,
Yeah.
not to say that Google didn't have their hands in it, but on top of that, you have like Prometheus and Grafana and all that, right? Those are all CNCF type work or projects.
Yeah, I went to KubeCon in Detroit this year, and like I was overwhelmed. Like I had no idea the ecosystem for Kubernetes and what kind of tools are out there. It's pretty impressive. So,
Oh yeah, if you've never looked at the Cloud Native Landscape site, right? There's like over 1,100 cards or products on this landscape page, right? That you can see, and it's all the various projects. It's pretty impressive.
yeah. Okay, so we're throwing out a lot of terms. I do want to kind of keep this 101 and like talk about like can you guys explain to me, as if I'm a child, what is Kubernetes and why it's important, and then also touch on like what is a container? Like let's start with the basics. Can you guys dumb it down for me?
Sure. Yeah. So Kubernetes itself is several different binaries, several different independent components that are all working together with several goals. One of them is orchestration, which I'll explain in a second, but it goes beyond that, right? I would say generically, what Kubernetes has now become is it's an abstraction layer on top of hardware. It can be used to control your cloud infrastructure through different add-ons and such. It can be used to reconcile things. But I don't know, if you want to simplify Kubernetes to its smallest functionality, the orchestration piece, as we keep saying, it's just a loop, right? It's just a loop that keeps checking on things. And so that orchestration comes down to, if I have some application that I want to have running and I want to have this many copies of it, or I need it to be able to handle this type of throughput, what Kubernetes will do is make sure that you have at least this many of this thing running. Or if you have rules that say, I need to be able to handle this many requests per second, you can actually have components that will manage automatically scaling out this thing. And that application is going to be in a container. And containers, you can kind of think of them as a very small virtual machine. That's not quite true, because a virtual machine can have its own kernel, certain things around system space versus user space. But if those are things that you generally don't care about, you can kind of gloss over that and ignore it and just treat it like it's a VM that has everything it needs to run. And so that's the container.
Only what it needs to run, I would say, right? Like the whole point of a container is it's stripped down to the barest of essentials to make it run fast and lean and have less security issues and all that stuff. But it's the smallest little virtual machine that you can make is the goal, is the idea.
Yeah, I recall. Go ahead, finish your thought, Matt.
Oh, and so Kubernetes, ultimately Kubernetes has become a control. Think of it like a control plane, right? So AWS changed everything when they allowed us to say, I want to run this virtual thing, right? I want a virtual machine. I want a virtual database. I want a virtual serverless function, right? You tell that API what you want, and it creates it in the back end, and you don't know how it's created. You don't care how it's created. It gets created and it runs, right? Kubernetes does the same kind of thing at this point, except for containers, but then it goes beyond containers into jobs, and now we're getting into the point where Kubernetes becomes it. You can spin up cloud resources with it, right? If you want that database, you can say, "Give me a database," and Kubernetes will create it for you, right? And then it helps manage it and it's got rules around how that stands up and how it does a rolling update and all of that stuff. But ultimately, you tell it what you want and it creates it. And it's an abstraction layer that you can apply over and over again. So I can have my Kubernetes cluster running in AWS, or I can have it running in Azure, and they both fundamentally run the same thing, right? I can reapply my same configuration file to either, and it'll kind of give me what I want. And that's the goal.
Yeah.
That's kind of how I see it.
You're kind of describing like infrastructure as code. Where would you kind of define the differences, the boundaries of what
Between
Kubernetes
what?
versus what Kubernetes is versus what Terraform is? Because you're
Right,
kind of
right.
yeah.
So they kind of both do some of the same sort of things, right? And we're talking about different tools in there. So, for instance, you can use Terraform, which is an executable where you feed it an opinionated statement of what you want, and Terraform goes and creates the things, right? Kubernetes you can get to work the same way with a specific CRD or platform, right? Or a tool. You add in Crossplane is what I'm talking about there, and you can tell Kubernetes, hey, I want this thing, and it will go build it, right? And fundamentally, in that case, Kubernetes is actually running Terraform on the back end, strangely enough. But the point is more of how you state what you want, right? I want X, Y, and Z, and it gives it to you, and that's the goal, right?
Yeah.
What
Yeah, and
Terraform won't do is it won't run your containers for you, right? It won't stand up that cluster and run it and keep everything running and do a rolling update. Terraform will build infrastructure and kind of you can write some sort of pseudo orchestration there, but Kubernetes kind of does all that for you.
Yeah,
Does that make
and I would
sense?
also add in that with Terraform, you're typically going to be very specific with the resources you want around the sizing, the SKUs that you're going to use or the compute instance types and all that. Whereas because Kubernetes is abstracting some of that away, like Matt mentioned, Crossplane is a very popular or at least commonly used infrastructure management component that you can add into Kubernetes. But you're also going to be able to, beyond just saying, I need, an EC2 instance that's, this extra large, whatever. Instead, you can kind of describe what type of workload you're going to have and have it be more reactive and kind of make some of those decisions just in time for you. Around scaling things. And so you're going to get that because it's managing multiple sets of resources. You've got your control plane, you've got all your worker nodes that, ultimately are different VMs, right? It's able to do some bin packing across some different stuff to be able to optimize hardware and be able to react to the shape of the work that's coming in at that moment.
Interesting. I think you touched on a few things there, Brendan and Matt, and I want to give the listeners like kind of a rundown of the various components of a Kubernetes cluster. So I think it would be helpful because I got a list. I don't know if it's definitive, but I want to, read off what I've got, and then you guys can fill in the gaps. And we've touched on it a few times already, but first component on my list is control plane. What is it? What's it do? And maybe we'll just take turns. Maybe Brandon, you take the first one, and then Matt, you take the next one here.
Do my best.
Yeah. Yeah. And the control plane is actually, you can break it down into a few different components, right? So your control plane, first and foremost, you've got your API controller, you've got your Kubernetes API server, and that's, how you interact with Kubernetes. Everything is API calls. So if you use kube control or kube cuddle or kubectl, however you want to pronounce the thing, it's one of the most we'll say diversely pronounced tools that I've ever encountered. But whenever you're doing those things, you're interacting with the API server. And then that API server is going to rely a lot on the state of the cluster or the desired state, which it is going to store in etcd. So etcd is a key value store. It's the most common store for Kubernetes, but I know for a while there, certain other things we're using like SQLite, other things to store state. But I think now, as of 1.19, I think you have to use etcd. It's kind of a core component of Kubernetes. So some of these answers depend on which version you're talking about, I guess.
Right.
But and then you've got. Oh, I'm sorry. Go ahead.
You went through the first three: control plane, API server, etcd. And then, Matt, why don't you talk to us about, if it makes sense, is scheduler is the next on my list.
Yeah. So the scheduler is the part of the cluster that will tell the nodes, or not the nodes, the containers where to run and when to run. So it looks at the various nodes and says, oh, there's room on this server. Go run your container there, or or not. And there you can set rules when you define things so that like you can say run these containers together or run them separately, or however, there's all sorts of ways you can set that up. The scheduler takes all that information and figures out where to run the workloads across the
Okay.
nodes.
And we'll go back to Matt, controller manager.
The controller manager?
That's something that rings a bell.
I mean, my understanding of it is that just kind of manages all of these various pieces together.
Yeah, I think it ensures that the desired state of the cluster matches the actual state.
Yeah,
That's
yeah.
kind of what, yeah.
Yeah,
then, of
those
course,
controllers are just those loops that I was talking about before. Every controller you put into Kubernetes, it's just a reconciliation loop that just runs forever.
Right.
Now let me say this: when you first get started in Kubernetes, you don't actually have to deal with really any of these things. They kind of run in the background, right? You interact through, say, kubectl. That's how I pronounce it. You use kubectl, which is a command line CLI based tool, to interact through the API, but you're not actually doing API calls. You're just running CLI commands, and it
Sure.
kind of handles all that stuff in the background, right? I put my manifest file, it's a YAML file, and say give me X, Y, or Z, and it just kind of orchestrates everything in the background and gives me what I just asked for, right? And
Yeah.
that's kind of the beauty of it. It kind of handles it all as one system. It's an opinionated system, but it's extensible and changeable and mutable, right?
Yeah.
The
Well,
deeper
thanks
you
for
go.
clarifying that. Because, yeah, as someone who hasn't worked with it, Kubernetes, like I see this long list of components, and it's kind of intimidating, right? But like you're
Right.
saying, you don't have to really. So just to round out the rest of my components, you guys have used the word nodes. Nodes is basically the
It's a
worker
server.
machines,
It's
right?
a server on which your containers are going to run.
Okay. And
Yeah, you're going
then
to
you
have
got,
the kubelet and the kube proxy. That's what makes a node.
yep,
Yeah.
kubelet was next on my list.
Yeah.
So is that like a agent that runs on each node?
Yep.
And then
Yeah.
your nodes actually host all your containers, is what you're saying.
Yeah,
Right.
so the kubelet tells the node, these are the containers I need to have running. I need to start these things. I need to keep them I need to make sure they're in a healthy state. If they're not, I need to report back that something's wrong. It keeps crashing, whatever. And then you've got the kube proxy, which is all about how do these things talk to each other? Because everything is, there's networks upon networks upon networks using load balancing in front of load balancing in front of load balancing. It's a lot of network layer shenanigans going on in order to make sure these things can communicate with each other.
And then the last thing on my list, rounding out the components, is the container runtime, which basically looks like there's some different options you can use for.
Yeah.
Well, there was two. There was Docker and there was Container D. There might be a few others, but in the most recent version of Kubernetes, it's all Container D.
Okay. The other
Yeah,
one I had listed was called CRI-O, which I've never heard of. I've
Cryo.
heard of Docker and Container D.
Yeah, Cryo is just a slightly different way of doing things.
Yeah.
Container D is going to be the easiest to use. It's what comes by default, with a lot of setups that you would use. It's also what Docker uses behind the scenes. So if you're using Docker desktop at the actual runtime level, it's using Container D. It's all
Okay.
that.
Oh yeah. For just for the record, we just upgraded 4 clusters in the past month and went from running Container D went from running Docker to Container D, and there was no issue. We just upgraded it. It happened. You wouldn't even know it happened. We
That's
didn't
good.
have to rebuild anything. We didn't have to change anything. It just all worked. Just a slight difference on the back end.
Yeah, the only difference that I ever noticed was the types of tools. If you really got down to the point where container, you suspected an issue with the container runtime and you needed to diagnose that directly on one of the nodes, that's where the runtime makes a difference because it changes the tooling you're going to use. But honestly, if you're at that point, you've got a lot of other problems and it's definitely well beyond a 101.
Yeah, I ran into one issue with it once that has been solved, but it was that was a deep thing. It
sounds like a deep rabbit hole.
Yeah, it wasn't a big.
So Matt, you kind of touched on this when we were going through the components about how a lot of these components aren't really things you're wrenching on or having to deal with. So I think that's a good transition to so what's the learning curve like for Kubernetes? Is it difficult to work with? Is it, just talk about the learning curve and then, let me know your thoughts on it.
Yeah. So the learning curve. So I personally don't think that it's terribly hard to learn. As a matter of fact, we have several brand new junior devs who have, started their first job 8 months ago with us, and they are learning Kubernetes right now. And how we have them doing it is they're just going through the tutorial stuff on the Kubernetes website. It's a pretty great resource, and it gets you kind of all these components, all the things you can put in your YAML file to build out what you want. Interacting with the cluster is pretty simple. It's a CLI tool that largely you either tell it what to do or you point it at a YAML file and the YAML file tells it what to do, tells it what you want, rather, not what to do, but you state what you want. Now, there is some complexity because things link together, right? So you can't just run a pod or a container and expect it, with a website on it and be able to get to it. You also have to build a service, and the service has to connect to an ingress. And so there's sometimes you get these chains of things that need to connect together. But once you've kind of learned how the various Kubernetes components link together, it's really pretty straightforward. So I wouldn't say there's no learning curve. There definitely is some as you work that out, but there are great resources out there. There's great tutorials, and there are tons and tons of experts on Kubernetes because, as you say, it's pretty popular.
Great answer, Matt. Anything to add to that, Brendan, in terms of the learning curve or the challenges of getting up to speed with Kubernetes?
Yeah, and as I mentioned, my kind of first foray into Kubernetes was as a platform engineer. So it was all about looking at this complex thing and then adding abstractions on top of it. And so when you ask how easy is it to get started or what's the learning curve, it's kind of like my children don't need to understand anything about a von Neumann architecture or how RAM works or what type of CPU I have to be able to play a game, right? So it's about what abstractions are available and what is the goal that you have. So for my kids, the abstraction is there's a link that they, a shortcut on the desktop, they double click that, the game starts and they're good to go. They don't need to know any of the complexity below that point. And I think it can be similar with Kubernetes. The way that I was doing it as a platform engineer is the individual developers, they had to know, how do I manage my container? And so if they could run it in Docker locally, they could be pretty assured that it would be able to run in Kubernetes. Now, in order to make that a smooth transition, as the platform team, we had to make a lot of decisions around, okay, Matt mentioned, you've got a service, right? We had to make decisions about what type of service are we going to use? Are we going to use cluster IP versus a load balancer versus node port? And those are all kind of just different ways of connecting into a thing. And then that service is going to set in front of some deployments, right? Or it could be that instead of a deployment, you're using a daemon set, or instead of those, you're using a stateful set. And that's going to depend on the type of workload you have. And those are kind of more one-time decisions. But once somebody has made that decision or made that decision for you, it's then very easy to keep that flow going, to keep it, to update that image. For example, let's just pick a scenario just to make it easier to conceptualize. So if you have an ingress controller, so you've got this thing running in your cluster where if I give it this host name and this path, it's going to route to this service, and you've decided that service is going to run as a cluster IP, and it's going to point to your deployment, which has a replica set with these pods. Right? That was one-time setup to make that all work. But now, if you want to add a new environment variable, well, that's just an update to the YAML representing that deployment. You want to change the version of that image, the tag of the image that's going to be deployed. Again, that's just updating the YAML for the deployment. From that point forward, Kubernetes is just going to reconcile that and make it just magically work. And there should be no reason that it would behave any different, from the previous version to this version, other than those few things that you've tweaked. So there's a lot of one-time decisions that need to be made, but you definitely don't need to understand the nuance of every single possibility in order to make things continue working once they're initially set up.
Okay.
Based on, as you were talking, one of the things I want to point out with learning, we were talking about learning curve. There is a lot of terms, and the nuance between, the difference between a deployment, a daemon set, a stateful set, and a replica set, and how those all interact. That's part of the difficulty, right? We throw out all these terms or acronyms, and that's stuff you got to learn.
Yeah, it's like that with everything though. I work a lot with AWS CDK, right? And there's just a lot to it's easy, right? But then once you kind of dive into it and see like all the different methods, all the properties, all the different constructs, I mean there's like hundreds of them. So yeah, I get it.
Yeah.
So I want to be respectful of your guys' time. We did get a bit of a late start. Also, welcome to the show, Tom. Thanks for joining.
Howdy.
I guess, I wanted to wrap up with do you have is there best practices that you guys could share to the audience? Because I know Kubernetes is a broad thing, but if there's some best practices that you think are worth noting when you're managing or building a cluster, please share them, and then we'll wrap up the show and let you guys get back to work.
Sure. Yeah, I've got my biggest pet peeve. Kind of we talked about how you can get going with Kubernetes really easily, right? If somebody else has done the paving of the road for you, you can drive down that lane super easy. But then what I've found is people start to understand more, and then they try to overdo things. And so, number one, most abused thing I've seen is the readiness and liveness probes. So these are things you can build into your container for Kubernetes to know if it's still healthy or if it's ready to serve traffic. And I think the worst sin that I've seen is where people try to have their readiness probe do too many health checks. So for example, if you have a web server, you've got an Nginx container that's running to show a website, and then that relies on some API servers to make certain calls, and then it's got a database that it knows that these API servers are going to call. If that Nginx container is doing a readiness check, or maybe even worse, a liveness check, that makes sure that all those things are up and running before it actually starts running itself, that can be a big problem. Because especially if you have kind of circular dependencies in there, what you'll end up with is one little hiccup on one little service can cause a cascading failure where all of a sudden everything thinks that they're in an unhealthy state. So my best practice there would be, instead of having your container try to be worried about all these other things and representing its own health based on that, instead build resilience into the application itself so that it can run, but give useful errors like, hey, I am running, I am here for you, but I couldn't do that thing you asked me to do because at this moment, this API isn't responding.
Right.
So build more intelligence into your application rather than trying to force Kubernetes to do things.
I've definitely been in scenarios like that, even on EC2, where it's just like the instance is trying to make sure it can connect to the database, right? And if there's a problem connecting to the database, all of a sudden all the instances think they're unhealthy, and so they all terminate themselves, right? So it's just like, well, yeah, there's that balance of like a proper health check. How about you, Matt? Any best practices you want to share? And we can come back to you, Brendan, if you had some more. But anything on your mind, Brendan or Matt?
So one of the things I love about Kubernetes is it allows you to really implement things like GitOps in a really pretty simple way, right? Because everything's just a YAML file at the end of the day that gets applied. There's a number of tools to do it, and you maintain a Git repo of your stated intention, and the tools will reconcile the two. That's, I think, super important to know, for recoverability, if nothing else. So I could throw my clusters away right now, just completely delete them and have everything back up and running in an hour or so, because I maintain what I want in a Git repo. So I absolutely 100% recommend looking at GitOps based tools so that you can do that. That's really an empowering thing.
Yeah, thanks for sharing that one.
Yeah.
Anything else
Yeah,
you guys
and
want to throw out there?
Sure. I wanted to tag on to what Matt just said, but also tying it back into something that Tom had brought up earlier is, when you have that GitOps tooling, let's say Argo CD or Flux, something running inside of Kubernetes, one thing that it can do beyond Terraform or other tools is Terraform tends to be a let's say CI/CD tool initiated thing. So it's part of a workflow where it's kind of a one-time thing. Whereas Kubernetes can actually reconcile that and keep things in the right state over time. So even if somebody goes in and maliciously or unintentionally changes something, it can switch things back. So that's one of the additional things that you can have from Kubernetes. But then as far as another best practice, I'm actually going to sneak two in. One would be making sure that you understand that if you have persistence, that you're using the right resources. And so within Kubernetes, that means you're using something like a persistent volume. So if you have this persistent volume, which could be tied to some NFS or something like that, so some sort of persistent storage, you need to make sure you're using a stateful set, not a deployment. And that's just something, if you think that's a situation that you're in, you should go look into that a little bit to understand it. But it affects how Kubernetes can do its updates, right? It tries to do zero downtime deployments. If you have a deployment resource with a persistent volume and you tell it to update, it can get stuck indefinitely. And you have to go out and manually delete your replica set to have it actually be able to bring up the new resources. So that's one thing. And then kind of similarly related, where you can get yourself stuck with resources not getting scheduled correctly, is if you try to take over the anti-affinity rules too much. So if you try to do too much around what's called taints and tolerations, so this is where you're saying this container or this pod can only run on these nodes, or it needs to run, these things need to be separated so they don't all run on the same node. If you do too much with that, you can end up in situations where you may be trying to do a cluster upgrade. For example, you want to switch to a new version of Kubernetes and you're upgrading nodes, and all of a sudden things that would normally be able to, for a period of time, run on the same nodes so that they all get shifted over to one while a new one's coming up, and then they get spread out again, stuff like that. You can end up with it just not working right. And that's, I think of that as being similar to people who use compiler hints too much with SQL queries. You're saying better than the optimizer, better than the tools that are built to do this, which may be true sometimes, but you'd better be certain that you're right about that if you're going to force it to do that.
Yeah, so, it sounds like you just easy to make it overly complex, introduce unnecessary complication, just like with any system. If you try to keep it as simple as you can.
Try to let the tools work for you. Try to let them work for you as much as they can. And if you find that you're having issues, resource contention, certain speed issues or whatever, then maybe step in and nudge things in the right direction.
Okay. Time check. You guys got a couple extra minutes? Because I did a couple questions. I wanted to just
Yeah, I'm
kind
good.
of. Okay, great. And I know Tom, you'll probably want to chime in on some of these where it's just like, what are scenarios where do you believe there's cases where customers or organizations shouldn't use Kubernetes?
Especially in the case of something new, right? You're building a new service, new application.
Yeah.
Yeah, absolutely. There are situations, right? So, and it's going to depend on your context, right? So if somebody were to come to me and say, hey, we are a .NET shop, we are running in Azure, we don't really have concern about cost or anything like that, as long as things are reasonable, should we use Kubernetes? I would probably say no. If they're just running their own applications, because there's already like Azure App Services, which are very simple to use, and they do a lot of the things from a, kind of like that developer perspective. Azure App Services do the same things for you without the complexity and number of things that could potentially break that Kubernetes has.
Mhm.
Now, if you want to, for example, have complete network control, and you want to have all your databases and your event, your message bus type things, all your event-driven architecture, everything all within the same network space where you have complete tight control around it, well, then using Helm charts to deploy all these things within Kubernetes could be an easier way to have that level of control. But if you don't need that, yeah, it'd be hard to convince somebody that they need all the components of Kubernetes just to run their application.
Mhm. So
Yeah,
Matt, if you could follow up on that, I'm really curious to know what led your organization's decision to go from ECS to EKS. If you could touch on that, because I think that's an interesting scenario.
Yeah. So when I started, we were running on ECS, and to be able to get in and troubleshoot what was happening in a container, they had to SSH into the ECS node and then connect from the using the Docker command line, and then get to the logs. And it was like this triple jump kind of scenario in order to really look inside what was going on in that container. On top of that, they had made some choices, like they were running multiple threads in each of those containers, and so knowing like what each thread was kind of doing was a little tricky. So what Kubernetes allowed us to do was kind of break that up, and nowadays each container runs one thread, and if it's having a problem, like if it's using a lot of RAM, it's only that one thread that we can deal with, and we can see it at a much more granular level. And we get all of the logs and we get all of the events out of those containers automatically slurped up into Datadog, or Prometheus, whichever way you want to go, and we can we have more visibility. It's easier to connect to a container through Kubernetes, and like we can get a shell if we want to, or get the logs for each of those containers in a much cleaner and easier way. But beyond that, as we move more and more into a microservice type architecture where we build a service as its own container, Kubernetes has enabled us to move a lot faster on that. We don't have to sort out how to stand up all the ECS stuff around each of those little microservices. We just have extra room on our cluster, and on our dev cluster in particular, it's not always highly in use, right? It's not. Those nodes have plenty of extra space, so we can run little containers around the main container, that because Kubernetes allows us to do that, right? And that's pretty powerful thing, right? It really has allowed us to move a lot faster and to stand up things just to try it out, right? We don't have to worry about all of the infrastructure around that, all the networking around that. We just tell Kubernetes, hey, run this container, and it'll do it for us.
Okay. So the follow-up question I have for you guys is, I think when I researched for the podcast, it's like you always hear Kubernetes is you can avoid vendor lock-in, right? Because you can run Kubernetes and
Sure.
you can run it on VMware, you can run it in AWS, you can run it in Google. Is vendor lock-in and like being? I see a lot of advantage of like leveraging AWS services because the integration between all the various AWS services makes it easier for me to deploy things, right? And it sounds like Kubernetes, once you get it up and running, is very similar. Like once you have it up, you can do a lot of neat things with it. But have you guys experienced like multi-cloud environments that are actually doing things in multi-cloud with Kubernetes, or is that just more of a? I've just never actually talked to someone who's like, yeah, we use Kubernetes because we're running 30% of our workload in the Google Cloud and the other 50% in Azure and then 20% in AWS. Like, I just don't, it doesn't.
Yeah. So the most recent State of DevOps report from out of Dora was the first time that I heard them talk about multi-cloud as a strategy to leverage the benefits of each cloud. Right. So it's not necessarily a homogeneous workload across them, but it's more, I want to use this database out of Google, and I want to use this application gateway out of Azure, and I want to use the compute instances out of AWS, something like that. Whereas I think it used to be this imagined scenario where you were all of a sudden going to go in and strong arm your cloud provider and be like, hey, if you don't give me a better deal, I'm leaving. I'm going over here and I can do it because I've got all this completely neutral stuff. And one, like most of the customers of any of the cloud providers, they aren't going to have enough leverage to be able to have that type of argument stick. And two, if you're doing that, you're probably missing out on some of the benefits enabled by that certain cloud, be it a specific type of message queue or database or backup solution, whatever it is. If you're trying to stay completely vendor neutral, you're going to miss out on some possible benefits there. But there is a lot of benefit with Kubernetes, not so much in the multi-cloud, so much as multiple infrastructures or multiple targets, because you can run Kubernetes locally very, very easily. Okay. Right. Whereas some of the cloud-based orchestration tools beyond Kubernetes might be a little bit more difficult to run locally.
Yeah.
I'll say, for a little while there, I worked at a company that was looking to run all their software on Kubernetes because it enabled easy upgrade at a remote site. So it didn't matter what, our client, didn't matter what they were running. If they were running in a cloud environment, if they were running in a local environment, the hardware, none of that mattered, because all we had to deal with was the Kubernetes aspect of it and package it so it ran in a Kubernetes cluster, and then bundle that up and ship it out, and it would run in Kubernetes because Kubernetes is Kubernetes, right?
Yeah.
And that was a great example of where it created an even playing field, right? It created that abstraction layer that separated you from that underlying infrastructure.
I think that kind of call back to what you said in the beginning of the show, Matt, where it's like the Cloud Foundation, I forget the acronym, CNCF. If you look at it, they've got 1,100 things that all work with Kubernetes, right? So if you're like an ISV and you want to build something and it runs on Kubernetes, right? I mean, you just kind of gain that benefit of like it can run Kubernetes in Google, run in Azure, run in AWS. As long as it runs in Kubernetes and you got a Helm chart that helps you spin it up, like you're golden.
Yeah, and that's my long-term goal, is that everything we do will run in Kubernetes, so that we have that option. We have the option. We're not stuck in AWS, because I've worked at a place where we had a client tell us they didn't want us to use AWS as our infrastructure because they were a direct competitor, right? Mm-hmm. Well, you're stuck if your whole solution is based on S3 and RDS right?
Yeah.
I mean, RDS, sure, you could run your database somewhere else, but what if it's Lambda functions, right? So getting everything so it runs in Kubernetes would allow you to move between clouds, not because I care, but because my client might care. And if I'm selling my software to them, I want to be able to run in whatever they're comfortable running in. And if that's a local machine or a VMware cluster or Azure or Alibaba, as long as it's got Kubernetes running, we can run inside of it. That would be a pretty powerful way to be. We're not there, but that's my kind of long-term vision, if you will, what I'm trying to work towards.
DevOps Supreme has spoken.
There you go.
Well, guys, thanks for giving us some extra time here. It's a really interesting topic. You guys are super knowledgeable. Really appreciate you taking time out of your busy days to come sit and talk to Tom and I.
Thank
hope
you.
our listeners, you found the conversation informative and valuable. And we'd love everyone to come back next week for next episode where we're going to be talking about an interesting topic that has not yet been decided upon.
Hey, if anybody has questions about Kubernetes or just wants to talk more about it, they should join the Discord server and
Yes.
speak
Yeah.
up, because I hang out there and willing to talk about it.
Yeah. Yeah. The intro to our show has a little, lets the listeners know about the link to join the server. So yeah, these experts are in our Discord server, excited to talk about Kubernetes. So please join, and we'd love to have you guys back again to talk about advanced Kubernetes topics.
Yeah,
Oh, yeah.
absolutely.
Yeah.
Take care, guys. Have a good one.
Yeah.